First, I want to tell you what is computer graphics. You may aware from the mode of communication. We can communicate in terms of text. We can communicate in in the terms of voice, and a number of mode of communication is available. So, according to me, computer graphics provides us another mode of communication. Means by the computer graphics, we can easily convey the information to the second party, or if we want to elaborate or explain some topics, then computer graphics will help us for the understanding purpose. So according to me, the computer graphics is another mode of communication. By the different methods and the different algorithms and the different approaches, we can done this task. So here we extend towards the basics, that this application of computer graphics are nowadays in the animations. You can easily see the computer graphics using a vital role: office automation and desktop publishing, plotting of graphs and chart, computer aided design, simulation and animation. So here these are the some important application of the computer graphics. How picture or graphics objects are presented in the computer graphics means how picture or the object will be displayed on the screen of the monitor. For understanding this, we need to first understand the pixels. That what is the pixels? First, we need to understand that our screen is the combination of some small point, and each and every pixel having a unique coordinate value. In mathematics, we have seen two-dimensional system, the x and y axis. In the same fashion, the point on the screen of the monitor will be distributed, and each and every point having a unique coordinate value. So this point that lie on the screen with the equal size, each and every point having a equal size for a single screen. This point is called the pixels. By the combination of the pixels or the displaying pixels, we can display different types of the images. So we can define a pixel point on the screen of the monitor is called the pixel, and each and every pixel having a unique coordinate value, a, a unique intensity and a color. Means each and every pixel having a unique coordinate value with the color. By the different colors, a pixel can be displayed. By the different intensity, a pixel can be displayed. Now, the what is the role of the resolution in pixel values? First, we need to understand the relation between the pixels and the resolution. Pixel may be consist of a number of size. A pixel can be big, a pixel can be small, but for a unique screen, the size of the pixel will be same. Means for a single screen, the size of the pixel will be same. If the size of the pixel will be decreased, then the number of pixels on the screen will increase, and with the increase in the pixels, the resolution of the screen will also increase. Means the number of pixels will directly proportional to the resolution. If the number of pixels will increase, then the resolution of the screen will also increase. So here we will able to understand the definition of the pixel, that what is the pixels. After the pixel, we need to understand the frame buffer. The frame buffer is the part of memory where the values of the pixel points and the pixel intensity will be stored. Mean a frame buffer is a part of the memory where the definition of the picture will be stored. Means if you want to display a picture, then each and every picture having a definite pixel. So frame buffer will store the values of that pixels, coordinate value of that pixels, intensity of that pixels, and the color of that pixel. So from retrieving these things from the frame buffer, the picture will easily displayed on the screen of the monitor. So this is the frame buffer. Frame buffer is not a new one. This is a part of memory that basically used for the graphics related operations. Next one is the frame buffer. As I already told you, picture definition stored in a memory area called the frame buffer. Frame buffer is also called the refresh buffer. And stored intensity values means frame buffer stored all the picture definitions, all the values of the pixels, intensity of the pixels, and the color of the pixels. So this is the frame buffer. Now, In the introductory points, I told you that we need to cover one basic point, that is the CRT, cathode ray tube. What is cathode ray tube? Cathode ray tube. This is the position of the cathode ray tube in the monitor. So each and every monitor having a cathode ray tube. Without cathode ray tube, a picture cannot be displayed. So first we will understand the functioning of the cathode ray tube. Here you can easily see that. See, this is the heater consists of cathode ray with the heated filament which is made up of cathode. This complete combination is called the electron gun. Electron gun will generate the electron beam. That electron beam directly will strike on the screen of the monitor. So here the right this fluorescent screen, this fluorescent screen is the screen of the monitor. So, and another thing is, you can see here the focusing coil and the deflecting coils and the anode. So what will be the process of this cathode ray tube? um, First, the filament of the cathode will heated to a particular temperature. After gaining a particular temperature, the electron will be generated from this electron gun, and this electron will strike on the screen of the monitor. Where the electron beam will strike, this will show a pixel. So, by how much intensity this electron will strike on the monitor screen, the pixel will be displayed. Okay. At the same time, so we need to cover this electron beam for the complete screen. So we need to just provide the particular direction to the electron beam, so the electron beam can scan the all the points of the screen of the monitor. So here you can see that the deflection coils. This deflection coil consists of the negative charge, and we also aware that the electron is also having a negative charge. So by amount of negative charge, we can control the direction of the electron beam. If on this coil, if the negative charge will be more than deflect, then the electron beam will be revert to the opposite direction. If the negative charge will be more as compared to the above coil, then the direction of the electron beam will revert to the opposite side. So by the amount of the negative charge, we can control the direction of the electron beam. So by this method, the electron beam will scan the complete screen of the monitor. Okay. As I already told you, this is the position of the CRT in the monitor. Each and every monitor having CRT. So this is the position of the monitor CRT in the monitor. This is the basic graphic system that will be required for displaying an image. You can see that the frame buffer, input output devices, memory, and processor. So this is the architecture of the graphic system. By using these devices, we can, with the help of this, we can display the images on the screen of the monitor. As I already told you about the displaying methods. So there are two types of basic methods that will use for the display purpose. Display purpose means the by this methods the picture can be displayed or any object can be displayed on the screen of the monitor. So first method is the raster scan display. By the raster scan display, uh, uh, a image can display on the monitor. So what is the method of this display? In a row-wise fashion, the electron beam will scan to the monitor. As we saw the electron beam in CRT, same electron beam will scan to the monitor in a row-wise fashion. Means from starting from the left hand point, all the pixels that will lie in a first row will scan by the electron beam. And in first row, if some pixels will be stored in frame buffer, then the electron will strike on that point and that point will be displayed. After completing the first row, the electron beam will move back to the first point of the second row, and in the same fashion, it will scan the second row. If any point from the second row will store in the frame buffer, then electron beam will strike that point. So according this row-wise fashion, the electron beam will cover the complete screen, and whatever point will be stored to the screen of the to the frame buffer, all that point will be displayed. So a image can be displayed by this. So this phenomena of completing one screen of the monitor is called the one frame. So one screen is the electron beam is completing the scanning of complete screen, then this is called that the one frame has been completed by scanning. After completing the complete screen, the electron beam revert back to the initial position of the first point, and for the scanning the second image or the second frame. So this is the raster scan display. Raster scan display always uses the horizontal scanning approach. In whatever pixel value will be stored to the frame buffer, all the pixel will be displayed on the screen of the monitor, because the picture definition will be stored to the frame buffer. There are two concepts. One is the horizontal red trace and second one is the vertical red trace. And after completing the each row, the electron beam revert back to the first point of the next row. This phenomena is called the horizontal red trace. And after completing the complete screen or one frame, the electron beam will revert back to the initial point of the screen.